Assalamualaikum warahmatullahi wabarakatuh. Thank you to the moderator who has given us time to present our paper. Before that, allow us to introduce ourselves. We are from Winsus Karyau, which consists of Ahmad Faisal, Kunaifi, Anda Putri Miftawati, and myself, Aulia. And we collaborate with Wahyu Anjarjati from Meteorological Station Class 2 Yogyakarta International Airport of Meteorology, Climatology, and Geophysical Agency of the Republic of Indonesia. Today, we will present our article entitled Design and Analysis of a Solar Power DC Irrigation System, a case study of a shrimp pond. Purworejo Regency in Central Java Province is one of the shrimp production center on Java Island. In this paper, we try to do a case study in one of the shrimp pond in Gerabak District, Purworejo Regency. We know to increase shrimp production, farmers are drawing water from the nearby rivers, lakes, and mostly sea, or making deep wells. Why they need to drawing water? Because of evaporation of the pond and the water pollution, it's necessary to circulate water. Water circulation is the key to success of shrimp pond. In traditional ponds, this water circulation process relies entirely on the tides of seawater. Now they use water pumps or use tools to enter seawater into the ponds. And additionally, they are using water turbines to circulate oxygen in the ponds. They're called aerator. So, for pond water circulating and circulate oxygen in the ponds using aerator, diesel engines are the main power source to do that jobs. Besides the fuel costs, there are additional costs for maintenance, such as replacing engine components, changing oil, routine checks. Each pond, 50 meter times 50 meter, requires a pump engine running 24 hours that consuming about 25 liters of diesel a day. This costs the farmer around 235,000 per day, or around 86 million rupiah per year. And this fee not including the cost of maintenance and the others. The dimension of shrimp pond used by the farmer is that a pond size 80 meters square to 1,200 meters square require about 3 water pumps running during the day and 1 pump at the night. The pond with area 1,040 meters square to 2,000 meters square require 3 pumps during a daytime and 2 pumps during night water supply. Besides the relative high cost of fuel, the problem is that sometimes fuel is not available. Although there's already a special quota provided for shrimp farmer, the amount is not enough. The cost of diesel engine and due difficulty in getting a continuous supply of fuel. In addition, because of using the diesel engine product waste, reduce waste, like fuel or oil spill, the pond becomes polluted. Some importing countries have certain standards, so sometimes shrimp from this area are rejected. The challenge is how to reduce the use of diesel as a power source, at least for a supply seawater to the ponds for the process of water circulation. So we propose a solar water pumping system, SWPS, to solve the issue of a fuel cost, fuel scarcity, and water contamination, because SWPS run with no fuel, because solar energy converting electricity and electricity using to power a pump. The method, general concept, SWPS configuration, SWPS planning and sizing, design data collection, that determining and size of SWPS component. The SWPS comparison we use a second configuration. Yeah? So the pump is submerged in the underground. So we need to calculate with some equation. Step 1, determine the minimum desired flow rate. Demand is daily water requirement divided peak sun hour. Step 2, determine the maximum allowed flow rate. We know calculated. Step 3, determine the total head. Yeah. Total head is total head static plus head dynamic, and choosing suitable pump. And fifth, calculating the daily electrical energy. So we know how much energy we need. And step 6, calculating the size of solar generator. After we calculated, we have a result like this table. Yeah? Daily water requirement, suction head, delivery head, etc. This specification we use. And the result is we need the design is we use pump with 600 watt DC submersible pump and 1,200 watt peak PV panel. And the PV panel is 4 PV panel, 2 parallel and 2 series. And the result is can give water around 6.3 meter cubic per hour. This efficiency is very good. It's 39% out of 41% of maximum. And the economic analysis is a good result. Initial cost around 135 million, 10% value add tax included, and the simple payback period is only 1.6 years, 1.5 year. So it's a very good. Yeah. And the conclusion. 1, the technical design of SWPS for providing seawater to the shrimp pond in Purworejo is relatively simple. The second is 5 cm replacement of water layer a day in 1,000 meter square pond requires only 1,200 watt peak PV panel and a 600 watt DC pump submerged in a borehole in the seashore. Third, the SWPS for the shrimp pond in Purworejo would be able to meet the daily water demand using every month as design month. 4, the financial analysis also show high feasibility to install SWPS in Purworejo with 1.6 year simple payback period, and SWPS would provide more than 20 years of free energy of the farmers. To draw seawater to the pond each day when the sun shines. And the last, an SWPS in Purworejo can provide not only environmental and social benefit, but also significant economic advantage, both at a farm and national levels. Thank you.